Hello community! It is the end of 2024 and we will delete RAG out of our systems because we have a new system called CAG. Let's have a look. Now, you remember TurboRAG from October 2024 and was a novel RAG system, and they used here for the first time the pre-computing and the storing here of the key value caches for the documents, and they told us, hey, we are 10 times faster than any classical RAG system. Now, at December 2024, just 4 days before Christmas, we have now the new publication, Don't Do RAG Anymore, when Cache-Augmented Generation, CAG, is all you need for your knowledge task, by our research colleagues from Taipei, Taiwan. So, beautiful. Let's have a look what this is here all about. First, there's a message that goes here. Our findings suggest that as long as all documents fit within the extended context length of our LLM, the traditional RAG system can be replaced by systems like O1 or Gemini. And you might say, unbelievable, how they dare to claim this. But you know what? It is so easy, because even Gemini 1.5 Pro, the old Gemini, already had a token count of 2 million token context length. So easy. And you know, the other argument is here, yeah, but we have a quadratic complexity with the transform architecture for long. Yeah, already 8 months ago I showed you the solution, ring attention, for real long context length. Or if you want, this video also 8 months ago, infinite attention here, where we already ask here, hey, is this substituting not a RAG system? So we have no external data anymore. Can we integrate this? And also show you other alternatives. But there's a second message in this beautiful new paper here from our colleagues from Taipei. And they say, with the LLMs featuring significant extended context windows, and maybe you are a developer that is already working with a 4 or a 6 million token context length, this paper proposes here an alternative to RAG, the Cache-Augmented Generation, CAG, that bypasses here completely the real-time retrieval of our classical RAG system. And the idea is simple. We just preload all the relevant external resources into our model, and then we cache its runtime parameters. So we have an original internal representation of the data from our self-attention mechanism in the decoder structure of a transformer. But I know what you're gonna say. You say, hey, wait a minute. And there are two arguments I can anticipate. You say, but hey, RAG has access to an extreme, huge vector store, you know? This is, of course, there are commercial stores and you have to pay them. And this is an established industry that we face. And this industry makes commercial and it tries to convince you that vector stores is all you need. But as you, my viewers, noticed in my last video, and this was so amazing that I saw that on this video where I showed you here, we don't need RAG, we can have another component ECL here in Inca. You showed me here, my viewers responded that nobody would put personal medical or personal financial data in a vector store anymore, where we have vector embeddings of our personal data. Nobody would do this. And there were 10, 20 responses by you, my viewers, that, hey, this nobody would do this into RAG anymore, no? And you know, this is beautiful because now suddenly what used to be our old classical RAG, we have now, if you want, a vector store, and we have now the idea that all the private, the detailed personal data go now in a secure database. And it is not anymore, like it was at the beginning of this year, that everything has to be indexed and everything has to be embedded and everything has to be a vector. Now that we break with this idea, we can move forward. So you told me, my viewers told me, hey, you put here the primary knowledge, let's say how to solve a new task in a vector store, in a vector embedding. And we built these mathematical spaces. We are expert because we can build our own domain vector mathematical spaces. And then we have here this detailed secure database. So if you want, we have kind of a separation of the know-how how to perform a new task. This is an instruction-based methodology from the real top-down individual financial data of Mr. Green and Mrs. Blue. So you see, we have here now a new idea how to handle this, and this is great, because if we now deny the vector store access to the private personal data, because we don't need them embedded in a vector representation, this is a huge step forward, because you know what's happening now? I showed you this in my last video here when we went beyond RAG. The pirates of RAG. RAG is not secure. RAG introduces challenges such as the retrieval latency, potential errors in the document selection, and increased system complexity, and it is not secure. And if you can get rid of all of that, that would be an interesting step, especially at the end of this year, no? So you might say, hey, wait a minute, is this kind of an aggregated view already something? Is this similar to this abstraction that Meta introduced when it moved from the large language model with the next token prediction to the large concept model? Is this concept somehow related? Yeah, a little bit, but I want to show you here more detail that you understand better that we are working here on a more general approach than Meta with its concept. Yeah, and the second argument, of course, is, hey, but RAG is established. And a lot of you write to me, hey, this is an established method. You show us new methods, new technologies. Hey, and I understand. You say, hey, I see 10 YouTubers, 10, 20 YouTube channels that are promoting here vector stores, commercial vector stores, and all those YouTubers tell me how great this is in their commercial ad for their commercial vector stores, where the vector stores pay the YouTuber for the commercial ad, how beautiful this RAG system is. And yes, I understand it. But, you know, if you are into science and if you have an open mind, you might ask, hey, now what the hell is this CAG in detail? So let's start here with a new methodology that will replace your old RAG system. It is a new framework that leverages here the extended context capabilities of the long context LLMs. Remember, Gemini already 2 million, maybe you work with stronger models, to enable here a retrieval-free knowledge integration of external knowledge. A retrieval-free. So in our RAG, we don't have a retriever anymore, we don't have vector embeddings anymore, we don't need it anymore. And you want? It comes out of the already what is implemented in Turbo RAG. Turbo RAG, going one step further, it just diminishes here that we need RAG. The development of Turbo RAG shows you that they already applied here the next generation here of knowledge integration, and it was done here by pre-computing the key value tensor structures and to cache them. And therefore, they could address here the computational challenges and the inefficiency that were inherent to the real-time retrieval in the traditional RAG systems. So, if you want, from inside of RAG, it destroys RAG itself, and you have a new phoenix arising here from the ashes of the RAG system. So, if you love RAG, hey, this is the new CAG. I hope I motivate you here with this video. Okay, back to science. And you say, hey, wait a minute, key value? I know key value, no? These are here in the transformer architecture. If we have here our transformer block or a multi-head self-attention mechanism here that we have here in detail, and we calculate here the tensor structures, and we have the learned weight parameters, and we calculate here with the softmax here the specific attention for the specific attention heads, and then we have our feed-forward network. Are those key value exactly those that we calculate here? Yes, you are absolutely spot on. We are really deep into the self-attention mechanism of a transform of the layers in the multi-heads, and this is what we're gonna use here for the next step. So, key value cache in the transformer model. You remember, transformer is a decoder only. We have an autoregressive generation, powerful mechanisms. Yes, you know this. But key values need to be recomputed if you do it classically for each token if we have the autoregressive generation. So that for every next token, all the key values need to be recomputed for every other token. And years ago they found, hey, if we cache those key values, tensor structures, so if we have key value cache optimization, storing the previously computed key and values and reusing them for the subsequent token generation, thereby reducing here the redundant computations and improving here the inference efficiency significantly. So key value cache is an old friend of us, but we never used it in the way that we explore in this video. So, classically, I would have told you in the transformer, why we do the caching of key value pairs to accelerate the inference of our LLMs, no? Because if you look now in absolute detail, you see at each decoding step, the auto-generative model performs here a self-attention over the entire sequence of our token to generate the next token x at the time t plus 1. So this process requires here the computation of the keys and the value matrices for all previously processed tokens, because we auto-regress if we look here at the complete left side for the time t. So notably, when generating here the token for the time t, the LLM has already computed the key and the value for the token for the complete interval t minus 1. So the key value cache optimizes now this process by storing the previously computed key value tensor structures, matrices, for t minus 1 and reusing them for the follow-up calculation, thereby only requiring the computation of key values for the next token x at the time period t. And this, of course, significantly improves here the computational processing here of our matrix multiplication, of our tensor operation. And if you want to see this in detail, this here is the cached key value matrices that we use here in detail. This CAG methodology, this is here the, if you want, GitHub repo. It is available to you. Just days ago it was published, 17 hours ago it was updated, but nobody has noticed it because nobody is telling you about it, because yes, I understand. If you're a YouTuber and you have a lot of revenues for doing commercial ads here for RAG system and vector stores, I do understand that there is here maybe some conflict of interest for you. But in this repo, you have everything that you need to try it out yourself. So maybe you are interested and maybe you give it a try. Let's have a very short summary. So what is this Cache-Augmented Generation? Why we don't have a retriever anymore? Why we don't build here extensive here vector spaces, extensive new mathematical spaces? Why can we go here with a cached internal representation of the transformer tensor product itself? Because it is so much faster, it's so much better, it is so much more performant. So, novel approach, enhance the performance of LLMs. And unlike the traditional, old-fashioned retrieval augmented generation, we preload now all the relevant documents here into the model, into the context during a pre-processing phase. So while we do here that we build up the vector spaces with the retrieval, what we do now is, let's say you're a company and you have your handbook of company processes. And let's say, 2,000 pages or whatever. 2 million tokens is about 20 books. So I think even with 2 million, the classic, it's a model that's free. Gemini is free to use here. You already have 2 million context length here in tokens. So now, if you want to upload here all the, quality management of your company, whatever you have, it is already enough. So you pre-process this in a phase, you pre-load this, and your LLM already ingests here all this external information and stores it in an internal representation for a future tensor calculation in the self-attention mechanism itself. We don't have to construct a workaround over a vector space, over a vector store. We directly stay within the operational mathematical operation of the LLM itself. We do not find other representation. We work here with this new self-attention from the external data. And we just store it then externally to the working directory of the LLM and just wait till a new query for this particular domain comes in. And then we upload here this pre-processed system. So, how does it work? Step 1, document. Gather all relevant documents, all your QM documentation, all your process documentation, or all your, How does mathematics work? How does theoretical physics work? Whatever you have, upload it. And these documents are domain specific and curated here. Beautiful. Then you encode it here in this pre-calculation. So the documents are fed into the LLM. Nothing else happened. No training, nothing. Just feed it in. You have now the key value cache here from the LLM encoder. You capture now this tensor structure because they are now the essential self-attention information here of the content, of the semantic content of all these documents in a format that you can immediately feed into your LLM. And then you have a cache reset if you upload the next thing of data. So whatever you store now, the key value cache of physics externally, or the key value cache of your mathematical things, or the key value cache of your operational things, or the key value cache of your quality management, you get the idea. So whenever a new query comes into the LLM knows, hey, I don't have just to rely on my original parametric knowledge that I have encoded from the pre-training and the fine-tuning and the alignment. I have external here a pre-calculated key value cache where all the quality management operations for this particular company are detailed. I have a complete process layout. So I need now to upload this knowledge. So I need to upload now this external key value cache into my operational memory, and I can immediately answer the query, and there's no RAG involved at all. Isn't this nice? Because in the old-fashioned RAG, you know what we had to do? We had the vector embedding, and retrieve the relevant documents in real time. The query is a high-dimensional vector space, and then we had to reduce the vector space, and we had to find similar vectors here with the query vector, with the encoding of the query vector, and we had our cosine similarities, and then we had the retriever, and then we had a re-ranker, and then we had a re-ranker to the re-ranker, where the first did 200 elements, and the next did only 100 elements. And my goodness, and the system became complex, and you paid more and more for the commercial solutions. And you introduced more latency, more potential errors, and the system was hallucinating like great. And now this new CAG says, I have advantages. Because everything is preloaded to your normal system. You don't have to fine-tune your system. You just upload it in advance. You don't have vector embeddings. And you are much more efficient because everything is already waiting in the inference phase. And if you have the inference, all this pre-computed key value cache memory that is stored, which contains now the LLM's internal representation of all the relevant external knowledge of the complete process management of your company, of the complete quality management of your company, or whatever, is now loaded into the LLM's working memory, given you have a specific query. So we have an inference computation where we just upload in the working memory some additional pre-computed key value cache already in the internal representation of the LLM. It is such a beautiful methodology, but a lot of ideas how to optimize this further. Operational advantages: reduced latency, error mitigation, and simplified architecture. Now I know that the central argument for this new Cache-Augmented Generation is that with the increased context windows capabilities of the LLMs, 2 million plus, preloading now the relevant knowledge directly in the model context and caching its runtime parameters, the internal LLM runtime parameters, offers a more efficient, robust solution than any classical RAG. And now I know what you're going to say, because it's exactly what I thought. Hey, and if I work on an experimental 8 million token context length LLM, but is the max content length really a limiting factor for this methodology? As it turns out, it is not. And here now I'm trying to a little teaser to show you what is happening. And I've never seen this in any other YouTube channel. I don't know why. But look, just in the week of Christmas, what is happening. Here we have a new publication on Archive here, December 27, just yesterday. A survey on large language model acceleration based on key value cache management. Or look at this from Tsinghua University and Fudan University. They look here at a multi-matrix factorization attention mechanism where they optimize these under string and key value cache constraints. Or look at this one. Here we have from Christmas, December 24, 2024. Here we have a pre-attention key value cache paper for University of Maryland, Yale University, and so on. So you see, look at this. For the day before Christmas, December 23rd, 2024. Google DeepMind goes here for cache augmentation that has a very specific offline coprocessor that operates here only on the model's key value cache. And this coprocessor augments here the cache with a set of laddered embeddings for a better decoding. And they demonstrated with a frozen LLM, they can be augmented with an offline coprocessor that operates here on the model key value cache and has further optimization of the performance of the LLM, especially for reasoning intensive tasks. To think more. So this is definitely a hot topic. Look at this. This is Purdue University, December 18. We already looking here for key value cache tensors with a 4-bit quantization. So the researchers are all trying to reduce this, to bring this here to maybe a consumer GPU system. Or look at this. This is from December 19. We have here an task-aware adaptive key-value cache compression methodologies for the long context LLM. I just hope that I show you, because you don't see something on YouTube or don't see something on Medium or you don't have a Reddit sub, whatever. It is there. This is happening. This is what is coming. Well, look at this here, December 18. Optimizing key-value cache compression in long context generation with a beautiful idea. Maybe I do a separate video on this. Those are the papers I currently read, and I think they are indicating here the path to the future. But if you think this key value cache is here just separated here in this week around Christmas with this 8 publication, no. Let's have an overview of the methodologies. We can optimize this on different levels. We have a token level optimization. This focus here on the fine-grained control of the key-value cache. We have a model level optimization on the architectural innovations, how we do this with the attention grouping in the non-transformer design. And we have a system level optimization, especially if you go here for the resource utilization and here especially the memory optimization. And this is real hard topics. The advanced memory management, how you handle this with these LLMs, that you are not restricted to 2 million tokens, 8 million tokens, or whatever. Imagine a system where you would have an almost unlimited memory management. So let's have a look at this. Start with the token level optimization for the key value cache management. And here from this literature, from this overview of the survey, look, these are just papers to optimize the token level optimization of the key value cache. The selection, the budget allocation, the merging of different key value cache. If you do chunking of different topics, different domains in multiple key value caches. If you do here the quantization, if you have a low rank decomposition. Yes, Laura, you have an idea. Static, everything. These are all papers, research papers that examine exactly this. Or we go here, key value cache management for the model level. Look, token level optimization, model level optimization, system level optimization, dataset and benchmark, how they are interrelated. Or let's have a look if you want a system level optimization for the key value cache management. The pure memory management, this is real something for specialists, for expert. The scheduling task, the hardware, aware design for which GPU are you, which are the possibilities of the new GPUs, how you can integrate here the hardware software optimization for this key value cache management, for this advanced reasoning where you do not need a rack system anymore. The research is simply amazing. You go from flash attention to all the other things. There are topics I don't even know. I have never read about this. But I think it's amazing what is currently, between the years, happening now on the key value cache optimization for our LLMs. So therefore, this is it. I hope this was just a teaser for you to understand. Maybe with 2024, we all come together and say, okay, we don't need a RAG system anymore. We further evolve, and now we have new technological possibilities. We have new ideas of the optimization. We don't need to build vector spaces. We don't need to build retriever that go on a vector embedding structure. We can have this in the internal tensor representation of the self-attention of our particular transformer architecture, if you go with a decoder only or whatever. And we have here a pre-computed Cache-Augmented Generation of external knowledge with the inclusion of all the possibilities that the key-value cache optimization on each and every level provides for our new AI systems in 2025. So I hope there were some new ideas. I hope you are a little bit here out of your comfort zone. I definitely enjoyed doing this video. Maybe you want to subscribe, maybe you want to see my next video, because I can tell you this was not the last video. We're going to talk about here better reasoning for our LLMs, better performance for our LLMs, and what are the new technology that you can apply, hopefully real soon, for your particular AI applications. Would be great to see you in my next video.